Okay, guys, we're going to be looking at question 4. Okay. Now, importantly, we have f of x, right? They've given us 2 graphs. We can see the graph below. It's not drawn to scale, but it does help us in our workings. We see that one is a parabola, x squared plus bx minus 3. The reason I know that's a parabola is because I know that that's a general form, okay? What I've done over here is I've written the 3 different forms of parabola. That's its general form, that is completed the square form, and that is its factorized form, okay? Where the x1 and x2 indicate, right, the x-intercepts of the parabola, okay? G of x equals a hyperbola. The reason we know that, again, this is a general form, okay? Then they've given us f has a turning point at C, okay? So we can just put here, this is a turning point, so we know that. And it passes through the x-axis at 1 and 0. Perfect. D is the y-intercept of both f and g. Okay, and the graphs f and g also intersect each other at e and j. Perfect. The vertical asymptote of g passes through the x-intercept of f. So we know that this asymptote over here, x equals 1. Why does a hyperbola have an asymptote? Because at a specific point, in this case, where x equals negative p, okay, we are going to have where this denominator equals 0. When you have anything divided by 0, it is undefined in mathematics, and that is why we have an asymptote. It gets close to the asymptote, but never crosses or touches it, okay? That is important. So let's just jump into the first question. So it says, write down the value of p. Okay, 4.1. Okay, so it says write down the value of p. So what did I say to you? I said x plus p, right, at the bottom of the hyperbola, because we know that that's where p is sitting. So I'm just looking at the bottom, because remember I said that this helps us with our asymptote. So x minus p, if we set that equal to 0, that helps us solve for our asymptote, right? So x equals negative p. Okay, so our asymptote here actually equals 1. Do you see that? It's where x equals 1, doesn't it? Right? X equals 1. Therefore, p equals negative 1. Okay, that is important. That also is intuitively correct because we know that when we shift this way along the x-axis, it is a negative. It'll be a negative p. If we move this way, it'll be a positive p. Right? That is the rules that we learn when we learn about the hyperbola. Okay, let's move on to 4.2. 4.2 says, show that A equals 3 and B equals 2. Okay, so we see that A is over here and B is over there. Okay, so what we're going to do is we should use a point that we have on each of the graphs to solve. Okay, so there's only one unknown for g of x, and that's A, because we know what P is now. There's only one unknown for f of x, which is b. So let's start with the parabola. I just think it's a little bit easier. Not necessarily. They're both equally sort of challenging. But what point on the graph, right, can help us over here? And I'm going to say for f of x, I'm going to use this intercept, 1 and 0. Right? Because they've told us that it goes through 1 and 0. And now it makes it a little bit easier for us to solve, okay? I'm going to say 0 equals 1 squared plus b minus 3, okay? So then I'm going to get negative 2 plus b, and b is going to equal 2. Okay, so now we've got b. It's fairly easy. Now, let us solve. Let me make sure you can see what I'm writing. For a, okay? So we know that this is negative 1. Sorry, I was going to write p there, but we actually know that p, right, is negative 1. So I'm going to put that in there. So we're just solving for a. So now we know, right, that this point on the parabola, right, point D, right, it is the y-intercept, right, of the parabola. So it's where x equals 0. So we know that this point here is going to equal 0 and negative 3. You might be saying, Margie, how do you know that? Remember, when we have a y-intercept, x equals 0, so x squared and bx is going to fall away. So then we know at this point it's going to equal negative 3. But also at this point, they intersect, don't they? right? And that's important because it tells us that D is the y-intercept of both F and G. So we have this point, okay? So let us sub that point in over here. That's point D. Is this point, is that I? I think it's I. Okay? 0 and -3. The reason it's -3, again, y-intercept. Okay, let's substitute those numbers in. Okay, so A is going to equal 3. Okay, do you see what I did there? Okay, so it's all about finding points and subbing them in. In each of these, there was only one unknown, so you only needed 1 point. You didn't have to do simultaneous equations or anything like that. Okay. Next question. Calculate the coordinates of C. Okay, C is the turning point of f of x. Okay, so let us write that down. So C is the turning point of f of x. Okay, and f of x equals x squared plus 2x minus 3. Where did I get the 2 from? From my previous question. What's important with these questions is they often build on each other, so it's important to do them in order. Okay, so we have that. And remember, this is important. There's 2 ways that we can find the turning point, right? One way, we can just say the x value of the turning point equals negative b over 2a, which in this case would be -2 over 2 times by 1. So we know that my x value would be -1, okay? Or we can get the derivative. Remember that the derivative, when set to 0, will give us the x value of the turning point. So f dashed of x, right, equals 2x plus 2. We set this equal to 0. Right, and then we see it gives us the same answer. Okay, this is important. If you're not comfortable with the derivative, do it this way, but this way is also equally quick. Remember, when we do a derivative, you basically bring the exponent down, subtract 1 from the exponent. Here, we just take the 2 in front of the x because the x falls away. It's very important that you remember how to take a derivative. Okay. So now we have the x value of c, but we need the y value of c. So let's just add it in, okay? So f of x equals y, right? So y equals -1 squared plus 2 -1 minus 3. So it's 1 minus 2 minus 3. So the y value of c is, oopsie daisy, I didn't show you the space there. I didn't show you what I was doing. Okay, derivative or this turning point method. Remember, you have to learn that off by heart. I'm substituting that x value back into my original equation to get my y value of c. Subbed it in, -1 squared plus 2 times -1 minus 3. So my coordinates of c are -1 and -4. Now, let's just quickly go back and check whether that makes sense. Okay, on our graph, C is in the 3rd quadrant. That is where x and y are negative. Therefore, it does make sense that both the x and the y coordinates are both negative. Okay, so that makes sense. Okay, make sure that you know how to do this. 2 approaches to finding the x, 1 approach to finding the y, and then write your final answer. Okay. Okie dokes. Let's now move on to 4.4. I'm going to make sure you can see it this time. Apologies for being all squishy with my other work. Okay, so 4.4 says write down the range of f. Okay, so f, remember, is the parabola. When we say range, it's talking about our y values, right? When we say domain, that's what our x values are. But it's saying, what are the range? Where do the y values fall for this graph f? So we see that the bottom y value would be -4. The reason we know that is the y value of c, which is the turning point. So we know that y, right, includes -4 because that's where c is, and it goes to positive infinity. Now, important, right? You cannot put a hard bracket with infinity. Infinity is a concept and not a number, okay? You can only put hard brackets when there's a number, okay? Infinity just means it goes on forever. It never ends. Soft bracket. You could also write this as y has to be greater than or equal to 4, okay? They're testing whether you understand what these specific terms mean, okay? Now we're going on to 4.5. Now 4.5 is an interesting one because it starts introducing a bit of trig. Now when you hear the word trig, you might be like, oh no, that's the worst. But it's not too bad, okay? So 4.5 says, determine the equation of the line through C, okay, through C, that makes an angle of 45 degrees with the positive x-axis, okay? That's important. They've given us an angle. Okay, so when they're giving us an angle, we kind of know that there is something we can do with that because we know that trigonometry, right, is the study of angles and sides of a triangle, okay? So it says, write your answer in the form y equals, okay, dot, not that weird sound I made, sorry. So it's a straight line, right? So we know that it's going to be like this. So what we need to find is we need to find M and we need to find C. Okay, so what we're going to do is we're firstly going to draw this in because sometimes it's a little bit tricky to see. So I don't know if this is completely accurate, right? But I'm just drawing a general line. Okay, so it's basically this line that goes through C. It doesn't necessarily go through D. We don't know that yet, but it goes through C. Okay, so what we're going to do, and let me find this on our formula sheet. It would be helpful if I could find the formula sheet. Yeah, I seem to have lost the formula sheet, but okay, the formula that is on the formula sheet is this, right? Tan of theta equals the gradient. I don't know if you remember that. Now, you might be like, oh goodness, what does that mean, right? So basically what it means is if we made this line that we put here, okay, if we made that a triangle, which is what's important, right? When we're doing trig, we're always about triangles. We're all about them triangles. And we make this angle here, right? This angle here, theta. Same angle over there. Why are those the same angles? Because this line is parallel to this line, right? And these are corresponding, okay? So this is a line theta. Now, we know that if we want to get, right, opposite theta is O, this is adjacent to theta, and that's the hypotenuse, okay? What we want to get is we want to get the gradient of this line, okay, right? And the gradient of that line, right, we know that the gradient is the change in y over the change in x, isn't it, right? But we also know that tan of theta equals O over A, which is the change in y over the change in x. And that's why those two things equal. Okay, that's really, really important. So if we say tan of 45, it's going to give us our gradient, right? I absolutely love maths. It's so cool, man. So tan of 45 is going to give us our gradient. Now, if you're really good for your trig, you'll know that equals 1. But if you're not, plonk it in here, and you'll see that our gradient equals 1. Okay, so now we know that y equals x plus c. All we have to solve for now is c. Fantabulous, right? And that's easy enough because we know that this line goes through C and we have the coordinates of C. Isn't that just fantastic? Okay, plonk them in, okay? -4 equals -1 plus C, right? So C is going to equal -3. The equation of that line then equals, you guessed it, x minus 3. Do you see that, right? So it's actually not that difficult. When you read it, you're like, oh, dear me. But it's not that difficult. Importantly, remember this and remember my explanation, okay? Also, when you're putting it into a calculator, make sure you're on degrees. If you're on radians, especially for those of you who do AP Maths, right, you will get some funky-dunky answer, okay? Make sure that you're in the correct mode, okay? So now, that is the end of that question. Let's move on to 4.6. Let me also make sure that you can see what I'm writing because that's not helpful if you cannot. So 4.6 says, is the straight line, right, determined in the previous question, a tangent to f? Explain your answer. So now what is important, right, is there's two ways of explaining this, okay? And I'm going to explain it in two ways. So firstly, the answer is no. It's not a tangent. And there's two reasons. Firstly, do you see that this graph that we got here, this straight line, it has a y-intercept of -3, right? So it means that it actually goes through C and D, okay? The definition of a tangent is that it only goes through a graph at one point, right? It touches that graph at one point. Another definition of a tangent is that its gradient equals 0 at a stationary point, okay? And a stationary point is a turning point, okay, right? And that's where we are there. So if it was a tangent, right, it would equal, the gradient would be 0 at C, right? And it wouldn't go through 2 points. So it's two reasons there. No, goes through C and D. And the second reason is tangent at C should have a gradient of 0. Okay, that's important. So what they're doing there is it's more testing your understanding of what you're actually doing, right? It's easy enough to just get the graph, but they're saying, okay, what does that mean? Okay, so what it means is it goes through C and D. Okay, if you're not a very strong math student, right, and you're like, Margie, you are confusing me out of my mind, do not worry about this, right? What you want to do is you want to focus on things where you can get marks. Don't spend extensive time trying to solve this and getting yourself like riled up. Rather, go on to the next question and come back to this one if you have time. Okay. Let's now do the last question, guys. 4.7. So 4.7 says the function h of x, this is a new function, right, is equals f m minus x plus q, right? It only has one x-intercept at x equals 0, so at the origin. Yes, that is the origin. Sorry. X-intercept, so the x-intercept. So x-intercept, y equals 0. Okay, so this is the origin. Okay, so it's here in the middle by our girl O over there. Okay, so then it says determine the values of M and Q. So this one, right, what they are testing, guys, and this is like these ones always, when I saw them in tests, I was like, oh, okay, maybe I'll leave this one out. But we're not going to leave it out. We're going to smash it, right? What they're testing is they're testing your understanding of reflections, and they're testing your understanding of shifts. Okay, so let's first look at this. Okay, so h of x equals f m minus x plus q. I'm going to rewrite this just to help myself understand, right? I'm going to say it's negative x plus m plus q. Now you might be saying, Margie, why did you do that? But when I see a negative x, you know what I think? I think reflection in the y-axis. Okay, so we know what's happened here is we're going to take this parabola, because it is the parabola. Remember, f of x is the parabola. We are flipping it over, right? We are flipping it over the y-axis, right? Okay, then m means that we're moving it along the x-axis, and q means we are moving it along the y-axis. Okay, so if I flip this across, so I'm literally going to just do when it's just a reflection in the y-axis. So I'm ignoring m and q for the most part, right? So I know that it's one of its x-intercepts, right? So it's one of its x-intercepts is going to now equal x-intercepts. This is just one of them, right? Is now going to be, it's still going to be 0 for the y, but it's going to be -1, okay? Because we flipped it. This has now gone that side, okay? And C is now also being flipped, okay? So then I'm going to say C of the reflection, I'm just going to put a little thing there so you know that I'm talking about this, right, is going to, it's still going to be, right, still going to be -4 for our y, but it's going to be +1, okay, for our x, because it's now sitting in the fourth quadrant where x is positive, okay? So you can actually draw this if you want to. I might actually just draw it with another pen so that you can sort of see what I'm doing. So this is just the reflection, right? This is just the reflection. Okay, so I'm going to put there a big reflection. Okay. So now, what we need to do is it says it's only x-intercept. It's only x-intercept, right, is at the origin. So what we need to do is we need to basically move this up till it's sitting on the y-axis. And then we need to move it this way, right, until it is sitting on the origin. So basically, we want our graph to be sitting like this, because that's the only way that it can have one x-intercept, right, at the origin. So how are we going to move it up? Well, we know we have to move it 4 units up. So Q has to equal 4, because Q is a shift in the up and down the y-axis. So we know that Q is going to have to equal 4, sorry. Right? Then M, we want M to shift us that direction, right? We want M to shift us in that direction, right, towards the origin. So if we're sitting at 1, okay, we're sitting at 1 now, we want to shift it. So I'm going to say M has to equal -1. Okay, because if M equals -1, then we have moved to the origin. Okay, I've basically moved 4 units up, okay, plus 4, and I have moved in that direction, -1. Okay, and that is what Q and M equals. I hope that makes sense, guys. Okay, so that is it, and that is that question done. Okay, that's 19 marks, quite a big question, but not too difficult, just have to be really methodical. Sure, but my page looks like a solid mess, but that's neither here nor there. We are moving on to question 5. Good job, guys.